Yes, as I've been introduced, I will be present you today in this webinar the automation approach from Microsense. So we will show you the new idea behind the automation concept of Microsense. So let's go to the as on the beginning, small agenda, we will start with a small comparison between conventional IP-based conventional automation versus IP-based automation. We will talk a little bit about the advantages which this new approach will provide us. And then we will continue with some examples of best practices on this concept. So finally, this webinar will close with question and answers. So, small introduction in the beginning to Microsense. So Microsense is in general providing two business model or areas. One is the networking area. The second one is the smart building solutions part. This is what we want to talk about. And the smart building solutions sector is providing a bunch of products. You will see here, for example, the solutions in this automation area is divided in two parts. One is the lighting and automation, and the second one is the software, where we will later on see in this webinar. So the approach of Microsense is based on a network IP technology, because Microsense is from his origin a provider of network components. We have an own development manufacturing in Germany, in Hamm, where is our headquarter. And out of this product portfolio we had in the past, this network devices, we defined this new approach for automation. So let's go and start with the comparison, what is actually the conventional way and what is our approach. So I'm pretty sure everybody from you knows this concept. So you have a classical device like an HVAC unit, could be also something different. You have a cabinet where you have the automation parts and the cabling. What you see here is the typical conventional way of doing automation. You have a PLC and a switching cabinet on the right side, which is responsible for doing all the automation, and then over the cabling infrastructure is controlling, for example, this ventilation device. So this concept you will see anywhere you have something you want to control by a PLC. What is the approach of Microsense? It's a different one. So as I mentioned before, Microsense is providing only network components, and our idea or our approach was take the network and try to implement directly data from the field into the network, make the treatment inside the network, and make also the output of data out of the network. So the idea is, for example, to connect field components like sensors, like actuators, like cameras directly to the network. Maybe cameras is something more common to you because of the surveillance systems, but as the way you use to connect the IP camera to the network could be also used to connect other sensor information, or to drive an actuator, for example. So the approach of Microsense is really simple. You have on the top, you have a management layer where you run the smart building manager, which is the management software for the smart building solutions. You have somewhere in the background a network core, which is making is providing the network backbone, and connected to this network backbone we have our switches, which do in parallel to the networking also some smart functionalities. The nice situation or one of the advantages is that you can run the system step by step. So this means you can run smart room controller each other. You don't need to make the installation complete before you start commissioning, but you can do it this step by step. If something happens to a local device like this smart room controller, only this part is affected, not the complete system has a problem. And all the information you collect over the switches, for example, like here in the room, are available later on the management layer, our smart building manager. How does it look like in detail? We will see here. So I have to switch to the next page if the system wants to do this. Something is wrong right now. I couldn't go to the next page. Okay, so we can continue. To describe you the concept behind this automation approach from Microsense, we will start at this point at this room controller, or this point where we have the automation devices. We start with our switch, in this case a PLM. It's our industrial line switch, which is called here Smart Engine. To this switch, we can connect over PoE. For example, our smart lighting controller. The smart lighting controller is able to drive an LED panel on the on his output, and power and data are delivered over the switch, so that you have only this one patch cord from the switch to the smart lighting controller for the cabling, and on the other side, you can run conventional LED. Important is that in this case, you can use only LEDs without any integrated driver. So it's only the naked LED panel. And in this concept, we have several smart light controllers from 1 channel up to 6 channel. I will come later on this concept. But the general statement is you run over PoE a device in the room, in this case, LED light. So for sensor data, we are able to connect over an ocean dongle, an ocean protocol devices. This could be a wall switch, or this could be an actuator for blinds controls and so on. This communication happens wireless. So, and this allows you to use this Notion protocol supported devices to cover field components. Like I mentioned, temperature in the room, or a button on the wall, or blind controller. All those devices which are not able to support a Notion could be connected alternative with a smart I/O controller. It's the same concept like we have on the smart lighting controller. A PoE feeded device, our smart I/O controller, gets his data from the switch, or delivers data from the controller to the switch. And to this smart I/O controller, you can connect conventional valves, temperature sensors, switches, or all the conventional field components or you can buy on the market. So we support all the standard signals. So by this this part here, what you see shows you how you can get the connection to the field layer, to the sensor and actuators, how you can get wireless via on-ocean access to field components, and how you can get access to luminaires. Now, the information from and to the network are covered by this part. The next step is the intelligence. So inside the our switch, we have integrated an automation functionality. which is able to cover all those tasks. This means information coming from the field components, like a switch on the wall, or like a temperature sensor from the smart air controller, is sent to the smart engine. Depending on what application you have chosen, our Smart Director app or the Micro RTS, you can define a program or a configuration, and according to this configuration, the switch is doing automation. So this means in parallel to his network functionality or his network task, which is the major task for the switch, he has parallel a second one, which is automation. And so you can use the switch to run some automation inside the room. For example, light control, temperature control, blinds, and so on. So the programming of this automation layer happens over our Microsens engineering platform. This is an IC 61131-3 compliant automation or engineering tool. This standard is, I mentioned here, is a worldwide standard for industrial automation. So in this standard describes the way how to program and how to do automation in the industrial area, and also for other automation systems you use in the building, smart building automation or smart building solutions area. So we chosen this standard because it's worldwide known. The handling of somebody who is able to handle a system which is IC 61131 compliant, and this is the majority of the systems on the market, can also handle the same way our system. It works like this. You have a tool. You can write in this tool a program. The program will be compiled, downloaded into the switch, and this program is running the application or is the application, automation application you run on the switch. On the other side, you have access over smart devices like a smartphone, tablet, or a PC to the switch, because inside the switch we have a web server. The web server can do kind of visualization. In the past, we used this web server to do the configuration of the network part, but it can also run the visualization of the automation part. This means, for example, the buttons, like in this example, you use to run blind controls, for example, or you could define sliders for dimming the light, or buttons to control something else. So this functionality is also implemented in the switch, and what you see here is in general a switch which is on the one side doing his networking task. On the other side, he provides a second application next to networking, which is automation. And you can use the infrastructure you have, for example, installed in a building for doing the classical network task, also to run automation without further installation support. So I will show you here some best practices. For example, what you see here is a small box. In this small box, we have on the right side bottom the power supply, the PoE power supply of the switch. We have the switch and the expansion unit. Everything is pre-configured to connectors on the top. On the left side, we have some fuses which can use to provide power to some devices, but this is a small box you see here. We have developed a couple of years ago, which has cover all the functionalities, power supply of the switch, providing of power supply for some external devices, and this box is developed and represent one possible product, which could be, for example, a smart cabinet. And this cabinet could be used in several cases. If you remember the picture from the early beginning with, for example, this ventilation unit. We have again this unit. So in the beginning, we had the cable cabinet or switching cabinet on the right side connected to the cabling. What we do different is we take this box you have seen before. This box is connected to the backbone, to the management system via network. You use the smart I/O controller, which talked you before, to pick up local information like sensors, like connectors or outputs, analog output to drive a valve. And inside this switch is an application downloaded, for example, which is doing the controlling of this ventilation unit. In parallel, but you can use the same box, for example, in the suspended ceiling, for example, to run the smart light controller to control the light, or over an ocean or some direct connection, other data from the room. And the same box, which on the right side, left side is doing the automation for the cabinet, is controlling a room only by changing the application inside the switch. So the left side, we have an HVAC unit with the corresponding application. On the right side, we have room automation, and the only difference between both devices or both sides is you run a different software application inside the switch, so that you be able on the left side to control maybe an HVAC device, on the right side you do room automation. So this means you have one device, you develop once a cabinet like this, small cabinet, and you can change and over the different software or application inside, you can use this cabinet to applications. So the advantages, one of the biggest advantages, everything you do is based on the network infrastructure. This means on a Mqtt cabling infrastructure from the field to the management level. The IT standards, security standards you provide in the network are also available and valid for this concept. We use all the devices connected to the switches are run encrypted communication and provide a safe infrastructure. We have uniform communication. We have the unification of communication protocols and interfaces. What does it mean? It means that the only protocols we use for doing this communication between the field components and the automation layer is based on open IT standards. We have no proprietary protocols. Everything what we use is accessible for people working in the IT area. So this make it also very flexible to make adaptation from third-party devices as long as they use also open IT standards. The advantage of the cabling from the field to the management center has been mentioned in the top. We have a reduction of hardware components because, like I showed you before the example, this cabinet, the small cabinet we developed as maybe as automation node, can be used in several different tasks without the need to make a dedicated switching cabinet planning. Like I showed you in the early first page where there was the dedicated cabinet on site. And this means a reduction of hardware, means also reduction of planning time for the completely automation part. And this means also a big save of money for the conventional hardware tasks. On the other side, if you imagine that you have in the conventional bay a lot of cabling between the device and the field, for example, this HVAC device to the cabinet, you have a big bunch of cabling on between, and this is reduced because you have only the cabling on the device, the connection from the field components to the smart I/O controller, and the rest is connected only by an uplink. This could be copper, this could be also a fiber, and by doing this you reduce also the fire loads in the whole building. There's no need to run single cables from A to B. You collect the data in this smart box, and the transfer from those data to a to second place or to the management system runs over this fiber, for example, which reduce elementary the fire loads. Simplification of planning is one of the result of those advantages. We have the integration of smart lighting. Today we can run up to 90 watts on PoE infrastructure. So this means that with this 90 watt per port, you can realize a lot of applications in the area of automation. You can connect a lot of consumer on devices, so which makes the way to do automation more flexible. From the network, this 50 watts was, this presentation is a couple of days old, so right now the actual standard is rising up to 90 watts. Half a year ago it was around about this 50 watts per port. So in our case with the PLM, we provide the standard PoE over our switches, which is 30 watt per port. If we need higher power on the for the devices, we can use other switches, other PoE switches, which can rise up to 90 watts, like I mentioned. So, and what is also important, that our automation platform is compliant to this IEC 61131 standard, standard for worldwide industry professional PLC systems. So I will show you some examples. How does it look in real? So what you see here is the product portfolio for the smart building solutions and for the automation part. You have here on the left side, you have the smart light controllers, this SLC, smart light controller. On the bottom, you have the single channel one. The single channel provides only 30 watts maximum as LED light, connected the LED light to this yellow clamps or orange clamps. On the input side, you have a PoE port, which connects the device directly to the switch. The second RJ45 is to connect a smart sensor, like here. In the middle, you see the 2-channel smart light controller, which is going up to 50 watts per device. And the same way, you have a PoE port, which providing this power supply and data, and you can connect up to 2 LEDs. And on the top, you see here, this is the 6-channel smart light controller, which is able to get connected on a 90 watt PoE port. And you can run 6 independent light channels, feed it over PoE with data and power. In the middle, we have our smart I/O controller. These devices are also PoE feeded, so you have only this RJ45 connector. On this device, you can connect conventional devices, for example, analog sensors, dry contacts. You can run, for example, a valve, or all devices which could be controlled by 0 to 10 volt. And this means we support all the standard signals which are provided for sensors and actuators on the market. And over this device, you can connect conventional field components to the network. On the bottom side, we have here 2 sensors, are smart sensors. You can connect them, for example, to a smart light controller. And this smart sensor is showing data like temperature, humidity, occupancy, or brightness. This sensor, the smart sensor CAN bus, is the same, provide the same functionality, but this sensor is able to be connected in a daisy chain. This is a single Gense sensor. Both sensors could be used in our infrastructure. And yeah, let's see some practical example how it does look like in real. So on the the switches, I think, should be known. The micro switches or PLM, both could be used for running this concept. And it looks like so. For example, we have a solution using a PLM. You see the PLM on the right top side. This is a power supply, the PLM. Normally you can connect, you use this PLM to connect the notebook, maybe a voice over IP telephone, a screen. For example, this is the conventional way you use this, or the network part. But on the other side, you can connect over PoE, for example, smart I/O controller you see here. On the smart I/O controller, you can connect dry contacts, a card reader, normal wall button, or variable air volume boxes to control volume of air. For example, you can connect also over Mqtt. This is very important. All our devices support Mqtt as a standard communication protocol for the data transfer from the field to the switch, so that you can use these devices also for directly get connected into a cloud. In this case, we have also conventional in the market available gateways, like this gateways, for example, from Modbus RTU to Mqtt. So this allows you conventional Modbus devices connected over this gateway to communicate via Mqtt to our switch. The data getting from this part here, where we have Modbus devices, could be treated inside the application the same like data we get from the smart I/O controller. And final but not least, we have the ability to, over this Notion dongle, to pick up also information wireless, or from an Notion wall button or an actuator for blinds. All those field components shows here are available over Mqtt, over wireless, over this PoE connection from our device. Inside the switch, treatment happens according to the application inside the switch, and also the outputting of the data. This is one concept with the PLM. So, and here we have another approach where we don't use the smart I/O controller, we use only third-party devices. You see, this is a conventional third-party device as a remote I/O controller, which cover all the field components. The communication to this device happens over a gateway. This gateway, it's important that the gateway should be provide Mqtt on the other side, but we can also support Modbus over IP. So this is also possible. So you see, if you have a switch inside the room, which was used in the past for the room networking task, you can connect over a gateway, over Modbus IP, conventional IP devices, and the data from those gateway can be treated, and we can do the room automation. This was another approach, for example, over Modbus IP. I have two further examples. You see here Microsense microswitch with, in combination with the smart I/O controller. The same part here, office part. This is the conventional part, you know, and smart I/O controller is connected via PoE to the switch. This device delivers the power supply to those devices and pick up the information. The need of power for field components is quite less. For example, one of the biggest consumer is a valve, which roundabout takes 5 watt. All the other devices like card reader or sensors needs really less power, so that with 20 watts, which is a smart I/O controller able to run, allows us a lot of applications. Finally, so in general, this was the approach. Maybe I want to go, yes, on the next slide. I will make a small the conclusion of all this is we have a network which is able to do all the classical tasks we know from the past. networking. So for office applications and tasks, the same network is equipped with an automation task, which allows us to pick up over dedicated devices or smart air control devices, for example, a smart light controller, information out of the room and do automation. We provide security. The same security we provide for the networking task could be used also for those devices. And we have a big flexibility because the application, the task, is defined only over software. In general, we have, if you see it from the top down, we see only a network inside the building, which is doing automation. I think this is something which is, as approach, quite unique on the market. Microsoft has pushed it for the last 5 years, and we have realized, based on this concept, also projects worldwide. So this was the reason why I thought it's time to make a presentation and show you how you can do building automation in a different way, maybe from the point of view have learned to see networking, and to show you what is also possible if you do it a little bit, handle automation in a different way. So I think this was in general the webinar for today. This was an alternative approach for automation. Next webinar, this is only an info, is in 1 week. Then we will talk about PoE DC lighting out of the network. And I hope see you there. And right now I'm ready for your questions and your information you want to get from my side. So thank you very much for your attention, and I hope I could make you an interesting webinar. It shows you some new approaches which could be for you maybe the introduction in a new business segment.